Hi there, I'm Razzle from MongoDB University. When creating applications, it's important your users have trust that their data is safe. By dedicating just 1 hour of your time to taking our A300 Atlas Security course, you'll gain the skills necessary to ensure best-in-class security for your MongoDB Atlas deployments. Enroll and take the free online course at your convenience at university.mongodb.com.
You're listening to the MongoDB Podcast. MongoDB Podcast? Exploring the world of software development, data, and all things MongoDB. And now your hosts, Michael Lynn and Nick Raboy.
Hey, would you do me a favor and just introduce yourself to the audience? Let people know who you are.
Sure. David Daly. I'm a performance engineer at MongoDB. Been here about 6.5 years, doing all things related to understanding how MongoDB performs, how fast it is, how stable it is.
Fantastic. And of course, as always, we have Nick. How you doing, Nick?
I'm doing great over here, Mike and David.
So today we're going to talk to David about his day job in performance, but also let's get a little bit of a background on David. Tell us a little bit about yourself. What did you do prior to coming to MongoDB?
Sure. I worked at a research lab for a number of years, working on computer architecture. I was working on the design and modeling of processor chips. So really low-level stuff, touching memory and caches and all sorts of low-level stuff that most people have no idea what I'm talking about when I tell them about it.
Well, that's impressive. Are you comfortable talking about what processor architectures you worked on?
Sure. It was at IBM, so it was the Power architectures. Worked a lot on, say, the Power 8 processor as it came out, and was involved in a lot of stuff related to the caches and memory subsystem for it.
So more on the software side of or the firmware side of the chip architecture?
Well, no, we were really early on in the process. So in actually designing how the chips were laid out, the features and such, I didn't touch any transistors directly, but at the block where you're talking about blocks of things and how they talk to each other and the sizes, and then doing simulation models to see how they perform before you go invest a lot of money to actually build the thing.
Are those chips still being used today?
Yeah, they are. In fact, Mongo runs on them. We have a contract with IBM to run MongoDB on them.
Awesome.
So how did you get into computer architecture? Were you a young programmer?
Not sure I was necessarily a young programmer, but I was always into science and technology and computers. It's kind of a boring story. I was, good student in science and math. I went to school for computer engineering. I knew I wanted to work on computers, and then continued on and got a PhD in electrical engineering. All the times, something related to computing and performance and reliability. Yeah.
So how did you get into performance?
That was a little more serendipity. So after I finished my undergrad, I was looking at grad programs and looked at a lot of places. I ended up going to the University of Illinois. And one of the things you do is try to find out who are you going to find an advisor to work with and a project to work on. And there's a huge number of projects. I didn't go in saying, oh, there's this one problem I got to work on. And so I talked to a lot of people. I had a friend who had gone on to a particular research group and was doing well. And I ended up in that same group. I guess I seem to follow people over time because this ties in later to Mongo.
And you said you've been at Mongo how long?
6.5 years. Well, it's a different perspective. I spent just under 10 years at IBM. And when I left IBM Research with just about 10 years, I had the comment, oh, so you haven't been here that long. And now being here 6 years, it's like, oh, you're in the rarefied air. Like, wow, you've been around for so long.
So we're going to talk about performance today, but we will get there. I understand you also participate in a few social clubs. What do you do outside of work?
Sure, I do a bunch of things. During the recent times with the pandemic and the shutdown, a lot of time's been spent. I'm a runner, so that's something that hasn't changed over time. I can keep running. I like to bake. There's been a lot of stress baking going on during the pandemic. I've upped my game a lot, and I've gotten to share a lot of that at work. We have a group that likes to share those things.
Are you in one of those sourdough bread groups that I keep hearing about?
Well, so we have a group that started before the pandemic, Cookie Club, where we would get together once a month and share baked goods. And so that's we have a Slack channel for that because we got a Slack channel for everything. But that's turned into a lot of sharing. Hey, what did I bake this week on there? And there's been some really creative, interesting things. There's been a lot of bread in there too. There's definitely been a lot of sourdough baked in my house.
I think there's an interesting Venn overlap of people that are interested in baking, not just cooking, but baking, and people that are into computer science and the real deep technical aspects of software. So it's interesting to hear you're into baking. So tell me a little bit about the focus that you have at MongoDB around performance testing. Can you talk a little bit about your role and how you approach ensuring that performance is the best it can be possibly at MongoDB?
Sure, and that's really evolved over time. So originally, there was a lot of building out and guiding infrastructure so that we can automate testing of performance. More recently, I've gotten to play with those tools a lot more. I like to call them my toys, and use them to ask interesting questions about the server. How does it perform in this situation? What happens if I do X? What happens if I run it on the largest instance AWS will give it to me? Can I get all the performance from it? And so that's a big part of what I do. I also get to try to, I get to work with a team of wonderful people that we've grown with different skills. But we also get to build workloads to model what actual customers do. It's an important theme in performance. Ultimately, no one cares how fast MongoDB is at a certain operation. What they care is whatever they're using MongoDB for, they got to use, right? They care, is it fast enough for what I'm doing? Is it fast enough that I don't notice it? And so we want to model what they're doing well enough to understand, how it's performing, where it can get faster, make sure it doesn't get slower. We put in a lot of effort into making sure that we're not surprised by someone changing something and the server getting slower because of it.
So I have a few questions regarding performance, maybe in general. So when we talk about performance, are we talking strictly about the speed of something, or are we talking about maybe the amount of resources that it uses, or other things as well?
Yeah, that's a great question, and it's all of those things. It's not the raw speed. It's does MongoDB do what the customer needs it to do in an acceptable amount of time using an acceptable amount of resources? If it's using too much memory and that's costing money, that's a problem. If it takes too long and the customer can't hit their SLA, that's a problem. If it's good most of the time, but when there's a spike for, say, Black Friday, and if the server falls over, that's not good. And we want to understand all of those things and keep them from happening. We want to make sure that you get nice, stable performance, that we capture the things that are important to how our users use MongoDB.
So I've got to imagine the number of use cases has to be crazy. How do you try to approximate everything that a customer could do?
It's a challenge because I think the design space is practically infinite. So we've tried to work out from the common cases to slowly increase our coverage for more and more of what our customers do. And so right now, right, I'm focused on pulling in more representative customer workloads. And we want to start with what are the most common things so that we really build out that coverage. And then, as we filled in, we can get smaller and smaller niche things. But we want to cover as many of the customers as we can.
So, do you have any examples of what customers are asking in terms of performance? Like, are they asking, well, I need my replication to go from 3 seconds to 1 second type of things, or something else?
So I get to talk to the customers through other people. So I don't do a lot of direct talking to the customers. I frankly kind of prefer it that way. I can't screw up too badly. But they ask for everything. We have a lot of customers who really care that response time for some of their operations is really low and below some threshold. We have some others who care just about, does it get done in a certain amount of time? Can I get my batch job done? And so it's really about getting all of those things together and figuring out how we behave across all of those, and sometimes making hard decisions about, it, about which get better and which get worse. We want to always get everything better. It's not always possible, so we got to understand how many customers do one thing or another to make informed decisions when we do have to make those hard choices. Unless anyone yell at me, I don't get to make those hard choices. I going back to how I view and do performance, um, I'm a provider of information. So I track what's going on. Learn new things about how the server performs, and we bubble that up. And there's a large conversation with the engineering management, with the product teams, about then prioritizing what we do based on that.
So I don't want to get too far into the weeds, but I think it's important to cover the high level architecture of things that you look at. Like, what are some of the component areas that you look to, number one, track from version to version, and look to ensure that there's consistent performance across those areas.
Yeah. And so before going into that, I think it's worth adding, I was talking before about customer level workloads. We also have a lot of um, very much more focused workloads that exercise parts of the system. And so, and we get all the developers working on adding in focused performance tests for those parts of the system. And so we have a very detailed view at component levels of how things are performing. So, at the lowest level, we have the storage engines and the interface level above that. We want to make sure that the basic functionality of that doesn't get slower and hopefully gets more stable over time. We have a very rich query language and aggregation framework. We want to make sure that those operators and all those stages perform well. We have a lot of tests that are focused on those. On top of that, we have the replication layer. We want to make sure that as we're doing all of those other things at the lower level, that if we have a replica set, that we're able to keep up with the transactions. We don't have secondaries lagging behind and causing write latencies or other stress on the system. And then on the top level, we have sharding. So if we have a sharded system, we want to make sure that the sharding protocol is working efficiently as it intersects with all of these things. So we have eyes into all of those things and have a pretty good visibility at that level. And then you might ask, just as the question at the beginning of, sounds like the workspace is practically infinite. The interactions between levels is quite large also. So there's a lot of work in trying to figure out what is the reasonable amount of testing to do for each level, because you can't do everything times everything. It just gets you're going to boil the ocean. It's just not boil the ocean using AWS servers.
So I'd love to hear about some major improvements that you've experienced in your time working in this capacity. Can you talk about some things that really just jump out as, like, the light going off, and after you fix those, there were major jumps in the performance of MongoDB?
Sure. So I think it was the last year. I have children, so my sense of time is very bad. Um, I think it was in the last year we had a project that was specifically focused on replication and improving performance around replication. And it was really gratifying to see the project across its entire lifetime, because it started as a project to make things faster. It's the replicate before journaling project. And so as we were defining that project, or as the developers were defining that project, we included explicit goals about observability and testing of it. So we had performance tests in place before the changes went into place, and so we could see very clearly that this thing worked. So the idea behind it was, if you when you write to MongoDB, we journal the changes. That's a local write to the disk, and you know that it's been saved at that point. And in a replica set, we also replicate it. And the old behavior was the primary would get the write, it would journal it and do the disk write, and then it would send it to the secondaries to replicate. And if you're doing a W majority write to make sure that your write is written to a majority of nodes in the cluster, you have to wait for the write, the replication lag, the journal write on the secondary, and the acknowledgement before you can acknowledge. And we did the work so that the journal write on the primary and the replication could be overlapped. And so in some cases, you got a 2x improvement in performance there in the limit.
And obviously, there was a lot of concern about data loss. I mean, that had to be of primary concern. Pardon the pun.
Yes. It was a primary concern, and we made sure to have all the correctness tests in place ahead of time for that. And in fact, it's why we hadn't done that in the past. We had tried it and realized that there were edge cases and complexities that had to be taken care of. And so we made sure to plot out how all of those would be handled and how we would know that it behaved correctly after the change.
Yeah, I know it's a major concern for us. So obviously, the business has changed dramatically since you began your role. And when you first came on, people downloaded MongoDB and ran it on their laptops and maybe prepared their applications and moved them into on-prem deployments. That's the cloud. The advent of cloud computing and the introduction of MongoDB Atlas has dramatically changed that space. How has that impacted what you do?
Yeah, it's had a large impact. And one of the more interesting parts is we now have a lot more visibility into what our customers are doing because we manage those clusters. And so it allows a very nice feedback loop of us to be able to see in production, what are people doing? What are the things that are important to us? What are the things we need to optimize? What aren't? We have discussions these days where it's like, do we need to prioritize this particular configuration? And we can say, well, this many of our customers are using that configuration. It's really important, or no, it's not. So it gives us a lot more view into the system.
So since we have Atlas in the mix now, is there separate testing procedures that would happen for, say, Enterprise Edition, but the same type of thing? Like maybe a feature is released for Enterprise Edition, it's also available on Atlas. Is the testing procedure to evaluate the performance going to be the same?
So it's largely the same, but we've made adjustments. So we test, all of our testing is automated, and it runs in our regression environment, in our continuous integration system. And we've made sure that the system that we're modeling and that we're testing against matches up closely to Atlas, because that's the predominant use. We also updated our system so we can run directly against Atlas. For various reasons, we like to do most of our tests against systems that we control and provision under our own control directly. That's a lot of words. But try to really control them because we're really sensitive to a lot of parameters. that matter to us on performance testing, but matter much less for a production environment. But we make sure to also test directly against that production environment and run the same tests and make sure that we're capturing all of the important things and that we're not missing anything.
So obviously, the outcomes associated with your work benefit everyone who's using MongoDB because we're going to be able to ensure consistent performance across various workloads. But how can other developers benefit outside of just using MongoDB in its optimum state? Are there frameworks or documentation or academic papers that you publish?
Yeah. So over the last few years, we've tried to talk a little more about what we've done internally. And I'm really proud of the systems that we've developed and the technologies that we've developed. So there's probably maybe most useful for anyone trying to test their own software was we had a series of 4 blog posts on the MongoDB engineering blog about all the things we did to control test noise in AWS when we were testing there. The cloud is a noisy place. It's great for many, many things, but if you're running a performance test, you care that you have exactly the same thing each time. And if you're running tests a lot, you care about small differences. And so we did a lot of work to learn how to control that and really dial in and get reproducible results there.
I think this is the first time I've ever heard of the term test noise. Can you maybe just give a one-liner on what exactly that means?
Sure. So if you're running a performance test, you measure some number. The question is how many people who run performance tests run their test again and see if it gets the same answer. If you're running on a computer, you probably are not going to get the same answer. They're giant randomness engines. There's so much that you can't control on a processor. And so if you're serious about your performance testing, you need to understand how much that number is going to change every time you run that test. And that is the test noise. How much is it going to change? If I run the same experiment on the same software, how much is it going to vary over time?
And what kind of thresholds are you looking for when you evaluate that noise?
It varies a lot. I would like it as low as possible. In a practical point of view, we're trying to detect changes on our focus tests that are in the 5 to 10% range. Below 5%, it's usually just a lost cause. There are some things that we can, but a lot of things it's really hard. But there's other cases where the system, you may just be doing something that's hard to get the noise down, and we don't care about, if it's going to fluctuate 10 to 20%, that may be okay. Examples are latencies on some things. If you have something that's a very small latency, you may just care that it doesn't go above some larger threshold. And so we'll still test with those if needed. I would throw in also, so in addition to the blog post, we do have an academic paper where controlling the noise is one important aspect, but also detecting whether a change is significant relative to the noise is in itself a hard problem. I mean, if you're just comparing two things, there's standard statistical techniques, and you can do that. You run a lot of times, you put confidence intervals, you see if the confidence intervals overlap. But we run tests once a day or more often. And we want to know on a given day, on December 1st, did someone commit something that changed performance? And so we've utilized some really cool and recent math to detect when those changes show up in our test histories. And we wrote a paper that appeared in an academic conference last year about that.
Great. And we'll include a link to that if it's available online. I assume it would be.
Yes, it is.
Fantastic. What do you mean by recent math?
So we linked to a statistics article from maybe 2012. So a math professor who studies statistics wrote up what we're using in the last 2 decades. And people are still actively doing research on these things, and we're happy to pull them in.
So how tightly integrated is your set of testing into the release chain? I would imagine it would have to be right in line.
Yes. It's very tightly integrated. So we have a process with we have quite a process. So the tests run, say, every day. We have this automated system that identifies where it thinks changes are. We have dedicated people, call them the build baron, who look through those and triage those and open up tickets to get engineers to go look at them. And then I or someone from my team is periodically reviewing those, making sure that things are getting worked and that things are routed to the right place with the right priority. And then it's also being reviewed monthly with management, and the we have release engineers who are tracking things and track at the release point, making sure that there's no scary things that haven't been addressed before we ship out the door.
And I'd be interested to know how exhaustive these performance tests are. I mean, are you testing under, I guess, the most ideal scenario, or are you testing like maybe running queries when the server's on at load? Or I mean, what are we looking at here?
We try to do everything, and it's an area of where we're going to continue to build out. So we run probably most of our tests run near full load and see how it performs. But we run other tests at low load to see what's the latency in those situations, because that matters a lot. We've added scenarios where we look at what's the latency when we do, say, a failover. So maybe we're running wrong, not at full capacity, but with a good load, and you do a planned maintenance event. You upgrade a server. If you do this in Atlas, all three of your nodes will be restarted. What's the impact on the workload when that happens? So we're trying to do all of those and trying to expand continually.
So you're focused on the existing set of source code, the projects that exist today. To what degree do you have a possible impact on the future of MongoDB?
Sure. So we have a process for reviewing projects, and so one of the things that's been important to my team is making sure that not just that we do good performance work, but that everyone in the engineering organization cares about performance and does good performance work. So as new projects come in, we review all of the proposals that come through and make sure that in their plans that they're considering performance the right way. If they're adding a new feature, that there's performance tests for that new feature included as part of the project. If they're trying to make something faster or more stable, that we have coverage to make sure that it is faster and more stable at the end. And just in general, that they're thinking about those things and are asking the right questions. And it's been very gratifying to see, we review these documents and more we review them and see, oh, good, they asked the right question. They're doing the right thing.
Well, as a result of the work that you've done and your intimate knowledge of how MongoDB functions internally, do you publish recommendations for developers on how to use MongoDB?
So we definitely do. We view the team. One of our functions is to be a force for intellectual honesty for the organization. That's one of MongoDB's core values is be intellectually honest, and we try to be a purveyor of honest information about how MongoDB performs. Um, and as part of that, we've tried very hard to review and push on the list of things that people think they know, but aren't necessarily sure that they know. There's a lot of common wisdom in the world, and we want to be purveyors of science and not conventional wisdom. So the last time uh, we, as an organization, updated our recommended our best practices. Um, we, as part of our team, we spend a lot of time looking through all of the existing ones and documenting like what has real data behind it, what doesn't have real data behind it. And of the things that didn't have real data, some are really clear for one reason or the other. You can just not worry about them. But some others, we went and questioned them and did testing behind them. And that fed into Matt Keep had a series of blog posts on best practices, and our work there helped feed into that blog post.
And Matt Keep is our one of our very senior product marketing managers, right?
One other piece of information that we provide is when we get to the release, we have all this information from the automated testing that we're doing and that we've been following over the year. And so we write up an internal report that documents, here's everything that we know has changed about performance in this release. It's for internal use, but it gets used and communicated out into the release notes and communicated to customers also. So if things have gotten faster, we want to call that out and let people know about it. If things have gotten slower for some reason, we'd rather them learn from us than come yelling at us later. Like explain why and what you can do to avoid those situations. And sometimes there's things that got different. So they changed in performance in our tests in interesting ways, and something didn't necessarily get fundamentally faster or slower, but something changed, and so we document exactly what happened there and why. So that, as I said, gets used internally. Our technical support has that, so they know what's happening as things go in. And it gets fed into release notes also.
Well, David, this was a fantastic episode. I think that it's going to clear the air on a lot of things for a lot of listeners on what we do at MongoDB in terms of performance. I want to figure out if people wanted to get in touch with you, if people wanted to learn more. Do you have any plugs that you want to give out?
Sure. Well, you can visit my webpage, if nothing else. I have daviddaly.me. It has my blog.
And that's DALY.
Yes, DALY, the proper Irish spelling. It has my blog and a link to my the papers and such that I published.
Well, David, thank you so much for spending time with us.
All right. Thank you for having me.
Thanks for listening. If you enjoyed this episode, please like and subscribe. Have a question or a suggestion for the show? Visit us in the MongoDB community forums at community.mongodb.com.